Hypothesis testing for proportions, our tutorial. With the introduction of hypothesis testing, we now have a new statistical tool in our tool belt. Allison introduced the main idea behind hypothesis testing, and Jeff showed a few examples of how hypothesis tests can be used for proportions. The first example Jeff walked through was the results of a poll on the proportion of supporters for the Mayor of Toronto, Rob Ford. Here's the formula for the test statistic, and we can calculate it using R to obtain negative 5.17. For the p-value, we would like the probability below this test statistic, which we can obtain with the command pnorm. We could also use the binom.test command from the binom package, which we have previously installed. The binom.test command requires that we have the number of successes rather than the proportion. So if we know that 42% of respondents support the mayor, then we know the count must be 0.42 times 1046. Rounded to the nearest integer, that would mean approximately 439 of the respondents. In the binom.test command, we will enter x, the number of successes, 1046, the total sample size, and we will state our null hypothesized proportion of 0.5, and that the alternative hypothesis is p less than 0.5. Let's go through the output one line at a time. First, we can see that we have 439 number of successes in 1046 total number of trials. This yields a p-value of 1.144 times 10 to the power of negative 7. That is 0.0000001144. From the guidelines you've seen in the lecture, this p-value is extremely low, which will lead us to reject the null hypothesis. It provides very strong evidence for the alternative hypothesis, that the true proportion of successes is less than 0.5. In other words, we have very strong evidence that the true support for Mayor Rob Ford is less than half. Do note that the binom.test does not provide the test statistic, just the result. We can also see a reported 95% confidence interval, but be careful because this confidence interval is a one-sided confidence interval, which we will not focus on. And lastly, we see the sample estimate for the probability of success p-hat, which we started with. For an example of a two-sided test, we can recreate the results of Jeff's beer cap experiment. With 576 successes, or reds, in 1,000 total trials, we again obtain a very small p-value. So we can reject the null hypothesis and conclude with strong evidence that the true proportion of red is not equal to 0.5, or that the two sides, red and silver, are not equally likely to come up on a beer cap.